Our next talk is powered by BMBF, that is the German Ministry for Education and Research, and it also opens the Photonics Strategy Forum, so welcome again to all of our photonics experts. I want to take just a second before we bring up our next speaker to do a pop quiz. Does anyone know what the theme of this year's new festival is? It's 3 words. That would be too easy. That would not qualify as a pop quiz. I will throw in an incentive of the Red Bull of your choosing. It starts with unveiling. Shout it out, guys. No one read the promotional literature. Digital disruption. Now you all know. There'll be another quiz later. You can still win a Red Bull. And Germany is the market leader when it comes to advanced lighting technology. What does that have to do with digital disruption? Well, our next guest really believes that the photonics industry has what it takes to be disruptive. Why? Because it relies on people who are innovative, people who are creative thinkers, people who are willing to take a chance. People like you here in the audience, please welcome the Vice Chairman and the President of the Laser and Electronics Division at TRUMPF, a member of this year's Codan jury, Peter Leibinger.
Thank you. Thank you. Thanks, Sarah, for the nice introduction. I'm thinking you should maybe give the talk. You're so enthusiastic about my topic. So I'm going to talk about light, photonics, as explained yesterday, the technological use of light in an intelligent way. And it's really, in my mind, one of the most relevant technologies to mankind right now. And therefore, the 20 minutes I have is probably a bit too short to talk about it, but I will definitely try. That's where everything changed, is the title of this picture. Many of us know the situation, and of course we can agree this is where everything changed. This is the first picture, but it's a first picture in a different way. It's the first picture that was taken by a smartphone and transmitted by a smartphone. It's considered one of the most important pictures, one of the 100 most important pictures in the world by Life magazine, and it was taken by Philip Kahn, who took it on a prototype of a smartphone that he built himself while he was waiting for the birth of his daughter. He then sent it to 2,000 friends and family members, believe it or not, and it really was the first smartphone pictures taken and sent via the phone. Today, 200 million pictures, it's an estimate, are uploaded to Facebook alone every day. And nearly 2 billion smartphones will be sold next year, also an estimate. Philip Kahn, who is an inventor and a pioneer, took his company public and sold it for 300 million in 2005. I think this example alone makes visible how light and photonics is an enabling technology. This is photonics, what we're seeing here. And it is a disruptive technology. It did disrupt in this case. Photonics is everywhere, and we use it every day. Paradoxically, being light, we don't see much of it. For example, the internet is photonics. The internet would not be possible without it, and it would look like what I have in the picture behind me if it were made visible. The amount of data on the internet increased by 14 million times in the last 12 years. That's an incredible number, and it was technologically only possible to face this challenge through the use of photonics. The lifelines of modern society sounds pathetic, but I think it is real. The lifelines of our modern society and of our modern industry are made of light. Millions of kilometers of optical fiber connect us, and it is lasers that can switch up to 1 billion times per second that light up these fibers and thereby transmit our data. Light is everywhere in manufacturing today. This is not a typical case of manufacturing. I will explain what it is in a second. But today, lasers are the most versatile tool known to mankind in its entire history. lasers weld, cut, drill, machine, bend, harden, crack, mark. All these applications are performed by lasers in production every day. And many of the items that we use, from cars to iPhones, could not be made without lasers. It is a tool with unprecedented flexibility and unparalleled precision. And this example is the opening of eggs that are used in the pharmaceutical industry as biological reactors to grow certain medications. And it is done by lasers because it only can be done contactless by lasers. The spectrum of applications for lasers range from ships to chips, which is the next topic, really. The principles of laser lithography are the enabling technology for the chips that are produced every day. Without this technology, Moore's law would not be possible. Today's leading-edge chips have a half pitch, as they say, of 14 nanometers. If you compare that to the size of the rhinovirus that causes the common cold, which I'm getting right now, that's about twice the size. The rhinovirus would fit on this structure that I show on my chart just barely. It's twice the size of the common structures used today, 14 nanometers. We are working on technology called EUV lithography, which is also a laser-based method to make chips, which will keep Moore's law going, which is tremendously important, not only to the chip industry to keep that process going, not only to us personally, through the devices we use, we benefit from the shrink, but Moore's law has been a driver of the world economy for the last 30 to 40 years. Every 18 months, for free, the world economy gets productivity gains that is driving our growth. Without Moore's law, with the end of Moore's law, that would stop, and it would be a major disruption to the world economy. But through photonics, Moore's law will continue. Lighting is also photonics. Today, the energy consumption, the electric energy consumption of lighting around the world accounts for 20% approximately of electricity used. Through the implementation of LEDs, white light LEDs that were first realized at the turn of the millennium, this can be reduced by about 50%, by about half. That's a big number. And it is taking place as we speak. This equals a CO2 savings of about 750 million tons every year that is realized through the use of photonics, through modern lighting, through LEDs. As a side note, about 1.3 billion people around the world still live without electric lighting. LEDs and solar cells, also photonics, will enable many of these people to get electric light, which is not so much an energy or ecological problem, but it is a social problem, because light means education. It opens the door to education. So photonics, in this case, also enables a big social project taking place around the world. Photonics also enable completely new ways of looking at life. Novel microscopes enabled by photonics using fluorescent biomarkers allow us to look at the living cell for the first time. This enables us to view life as it unfolds and to understand diseases better. And it will lead to new ways to deal with big diseases like cancer. So photonics also enables medicine. In science, photonics, of course, is used as a measuring tool. Sometimes as big as this room, sometimes as small as just an LED. These lasers are used to measure distances, time. They're used in space telescopes, spectroscopy, etc. The Nobel Prize laureate, Professor Hensch, summarized the importance of light to science once with the simple statement, "Almost everything we know about the world we have learned through light." But what's the future? Why do we consider light an enabling technology, something that will merge our digital experience with our real experience. Let me start with lighting. Without light, as I just explained it, without the photonics, the world as we know wouldn't exist. I think that's evident. But I consider it more important that what we all envision as a future world, a digital world, without photonics, it would not be possible. Let's look at connected light. The mere substitution of conventional lighting through LEDs can save about 50%. I just explained that in energy consumption. Another 30% are possible through connected light simply by the fact that we use light if we make it intelligent, if we connect it via data links and equip it with sensors. We will use it only when we need it, and it will be off when we don't need it. It's a big step. But what's even more fascinating about this is that through connected light, we will be establishing a worldwide infrastructure that can be used for many, many other things. I'll give you an example. Connected lights will have sensors that will see if someone is there using it, but they will also, these sensors will then enable other applications like location services. If you think about street lighting, for instance, there are about 350 million street lights installed around the world today. If and when these street lights are connected and equipped with sensors and maybe cameras and maybe sensors that can measure air quality, we will have an existing grid that will enable location services, that will enable guiding services. We will be able to have surveillance systems that, for instance, can monitor traffic, that can guide autonomous cars to empty parking spaces, etc. We are harnessing an existing grid and make it available to mankind. Now take this idea into the house, into the building, where we also have lighting structures that exist. And you will have an entry door to the smart house, the smart home, or the smart factory that will enable you energy management, facility management, applications, for instance, for rental management, all will become possible through connected light. In other words, connected light is an enabler to the big topics of smart city and smart home, and it will be a game changer in the lighting industry, and it will be an enabler for the Internet of Things. Another big game changer, of course, that everyone talks about in these days is Industry 4.0. What is meant by Industry 4.0 in simple terms is the vertical and the horizontal digital link between processes. Let me explain. Vertically, what we are doing in Industry 4.0 is connecting sensor-generated process-level data via the machine, via the shop floor, into the cloud, where we aggregate this information and analyze it. What we will be able to do by this is to better utilize machinery that is already installed, and we will have better availability of this type of machinery. This will lead to productivity growth, linear productivity growth. The horizontal link is, simply put, a digital order-to-cash process through the use of digital twins. Now, what does photonics have to do with all of this? First, this will lead to an unprecedented push for flexibility in manufacturing equipment. The laser, as a versatile tool, as I explained it, can play a vital role here. But what's just as important is that optical sensors and measurement devices will play a key role in generating and providing the data necessary for what I have just explained. The opportunities and challenges are obvious. Photonics can be a key enabler for Industry 4.0. However, traditional laser companies, sensors, and machine factories will have to transform themselves to becoming a more software-centric hardware manufacturer. Digital manufacturing will drive the convergence of hard and software. I will give you some examples. The flexibility of Industry 4.0 tools I'm talking about will need to be able to interact with their surroundings. New types of machine interfaces will be needed for us to interact with them. Robots can thereby become what we call cobots. New collaborative robots, cobots, can move freely and safely amongst us through the use of vision-based sensor systems and through intelligent algorithms. Yesterday, a startup, what's the name? Tronics, no. Tronics? Roboception, thank you. Roboception was awarded the Cluster Prize of Photonics because they offer exactly that type of vision system. So novel camera systems are what is needed, that are able to perceive their surroundings, that are able to, like we do, detect motion, detect skin, really anticipate what is going to happen, and thereby make it safe to be amongst them. And again, these are photonic systems that I'm talking about that will enable this human-machine cooperation. There's a study by Berkeley Research that says, if and when we solve this problem, 500,000 new robots can be sold each year, which is a huge jump from today's robot sale numbers. I think it's about tenfold. A big topic, a hype that everybody is talking about these days, of course, is 3D printing, laser additive manufacturing, and it is another enabler to Industry 4.0, as I think. 3D printing is the only seamless connection from digital to material that we know of today. It is truly seamless, from electrons via photons to the part. And it is going to be an important manufacturing method in Industry 4.0. Of course, we all know the GE example of the fuel nozzle, and we have heard about the big GE deal, and I think it is a good example of what is going to happen and what is ahead of us. Displays. 90% of the information we perceive, is through our eyes. And it will be through new types of displays that we are able to interact with the digital world. We will have displays such as this mini beamer that is displayed on my slide here, that is made up of 3 small laser diodes that are able to transmit the colors red, green, and blue. And these types of pico beamers will be cheap and small and be installable on all kinds of devices. And through motion detection, it will be a new window into the digital world and offer a new ability for us to interact with the digital world. Of course, OLEDs are the big screens of the future, and the reason is simple. They can do true black. What I mean by this is, while we are used today to LCD screens that have a contrast ratio of about 1500 to 1, OLEDs will be able and are able to achieve 1 million to 1. What is interesting in the context of photonics here is that OLEDs are photonic in 2 ways. Obviously, they're a photonic device, but we would not be able to make these without photonics. All OLEDs today are produced in Asia. I think probably all of them in Korea even. But none of them could be made without photonics technology from Germany. Both the building block material and the laser machines that make these OLEDs come from German companies. Again, it is clear the display is our window into the digital world. Without it, we would be blind digitally. Another hype, autonomous cars. Of course, we know car lighting, LED lights, laser lights are really cool, but what's more important is the use of light in autonomous cars that we don't see. What I'm talking about is visible and infrared cameras. I'm talking about LiDAR systems that take millions of data points each second, which are absolutely necessary to make autonomous vehicles possible. And here again, I'm not only thinking about car, but I'm also thinking about factory logistics, which is a huge unsolved topic. When we're talking about photonics, we're talking about devices like this one. What you see on the slide is a micro camera that is 3D printed using lasers. It is a 3-lens camera that has a lens size, each lens of about 125 micrometers, and a depth of field of 3 millimeters, and it can be injected into the human body and used to monitor procedures or to diagnose illnesses. And it is just a small example, literally a small example, of how photonics will also enable us to change how medicine functions today. The list of topics are endless, and I will end with this one, which is trying to symbolize quantum technology, the next big leap. Of course, when we're thinking about quantum technology, obvious topics are topics like quantum entanglement, which will be the solution to ultimate safe data transmission. Or we're thinking about the quantum computer, which is supposed to become the next big leap in computer technology. What I personally am interested in, however, is ultra-fast physics, ultra-short pulse lasers emitting laser pulses in the femto or attosecond range. What is enabled by these types of lasers, an attosecond is the billionth part of a billionth second, are extremely high pulse peak powers. We're talking about peak powers in the range of terawatts, which is all the power plants in the world combined, but only in a very, very short time. One use of ultra-short pulses is, of course, short-time physics, looking at very fast processes in physics. An equally important one in my mind is the potential replacement of synchrotrons through lasers. Today, a synchrotron, which is used to generate particle beams, proton or ion beams, used, for instance, in medicine. A synchrotron of that type costs upward 100 million and has a diameter of upward 100 meters. It is at least conceivable that we will be someday able to make tabletop synchrotrons based on ultra-short pulse laser. My company is working on this. It's many years out, but it will enable new medical diagnostics and new medical treatments. We will be able to defeat cancer when we have this technology. And it's just a glimpse into the future, into the faraway future, what photonics will enable. I have to finish, and therefore I will come to my last slide. I think it has become clear that our world has changed, and the transformation we are experiencing is very highly dynamic. And how photonics has been a driver of this change, and it is a high-tech industry creating leading-edge technology for a worldwide 650 billion euro market in 2020. But what's more important is that it's not just a successful industry, it is an enabler of the digital world of tomorrow. It will lead to huge opportunities for our industry, but there will be large risks to manage as well. The opportunities are quite obvious. I think I have described a few successfully. But we have to be very aware that with these markets we are serving, with the disruption we will bring to these markets, we will be disrupted ourselves. If we are smart, we will be able to be the enablers. Our companies and our institutes will be able to be the enablers of this disruption. But it will, of course, also offer new opportunities to newcomers. And we will have to be open to change. We will have to change ourselves to seize this opportunity. So this is the reason we are here today. We are starting our strategic workshop today. After this session, not my talk, but the session, we will be up in the Cubus, and we will be discussing what the roadmap, the research roadmap of the future in Germany should be in photonics. We have a tremendously successful history of photonics research in Germany. I think it's probably the greatest success story of the BMBF in the past 20 or 30 years. And it is not intended to be self-praise, just to make that clear. But it is a real success story, and we have to work together and define together how the future will look like. And I invite you all to be up there in the Cubas with us and present your ideas and debate the presentations, discuss the presentations that are given.